welcome with another video. This is your Professor Dr.Mchem from Dr.Mchem Institute of Chemistry, University of St. John's, and what we are going to start today with is retrosynthesis. What is retrosynthesis? Right? This is our today's topic. So let's move on. What is retrosynthesis? Very interesting and very attractive. Something new. Not for the final year students, but at least for the ones who are listening. So what is retrosynthesis? Now, it was found by a Nobel Prize winner. Who was that Nobel Prize winner? Professor Elias J. Corey. Who was he? He was a Harvard University professor who gave this concept of what we call today retrosynthesis. So, retrosynthesis is a reaction in reverse. Okay, it's simply a reaction in reverse direction, heading back to the original molecule. Heading back, what? To the original molecule. It is represented by this arrow. You can see a black silver arrow here, right? It has got one open end and the other end is pointed end, and it is called a retrosynthetic arrow. Here, for example, you can see C, then a retrosynthetic arrow, B, then a retrosynthetic arrow, A. Now, what is this C? C is the target molecule. So, target molecule is represented by Tm. I will discuss later what is this. I will let you know because there are a few terms which you are supposed to learn before we should start this topic. That is, what is target molecule, what are disconnections, what are synthons, and few more terms which are supposed to be learned by you. Okay, so here in this slide, C is the target molecule. We will disconnect it, giving rise to an intermediate B. That is this one. This is the intermediate. C is the target molecule. Fine. We will disconnect it and we will form what? The intermediate B. Which on further disconnections will give us back from where we started. That is A. From where we have started. So, in retrosynthetic analysis, we do need to break the target compound by either two different types. That is either by a disconnection or functional group interconversion, which is denoted by FGI. Now, what is disconnection? Disconnection is a bond cleavage between atoms, or simply a cleave a bond and transform it back to the initial compound. And what it is a hypothetical approach. It's not something real. It's something imaginary. For example, now here I would like to give you an example. If this is a molecule, for example, this is a target molecule. It's an ester, it's a target molecule. I've written here also Tm, that is a target molecule. And now what happens? What is the target molecule which you get after that? That is the product of the reaction. When the reaction progresses and you get a product, that is called a target molecule. So this is supposed to be a target molecule, an ester. Now what happens? Here you can see that if you disconnect it, now what is this red line? This is the sign for the disconnection. I've written also here disconnection. If you disconnect it between the carbon and oxygen bond, if you disconnect this one, this carbonyl group is here, and if you disconnect this carbon oxygen bond, what will happen? That you will use a retrosynthetic arrow. You will put a retrosynthetic arrow, and the bonds, whatever bonds you are going to disconnect, you are going to you are going to write it over here. Here also you will write it down here, CO ester, because this is an ester which you are going to break. So this is bond to be break. You are going to write down on the now in today's video lecture, I have made you learn what is retrosynthesis, and I have made you learn what is a target molecule. This was a target molecule in our case today. That was an ester. And then I explained you how you can form the synthons, right? And one thing which I wanted to make clear, that you cannot add them together. There's a sign of addition here. You're not going to add them together to get the desired product, right? To get the synthetic equivalents. No, you need to join them with other ions, right? Other counter ions to get them back to their most stable, most state. Okay, and the synthetic equivalents, you finally learned what are synthetic equivalents, which are these. These are the synthetic equivalents which you got after this, and how you are going to represent a synthetic equivalent by these three lines. When these three lines are drawn, it means that this is something to do with a synthetic equivalent. So the synthons, they will be converted to the synthetic equivalent. So today I think I'm quite successful in explaining you in short what was retrosynthesis, that is the reaction in reverse, right? And what is a target molecule, which was this one. This was right, which is supposed to be a product you got in or in the end of the reaction, or product of the reaction, right? When the reaction is progressing in the forward direction, you get a product in the end that is called the target molecule, right? And you have come to know what is a retrosynthetic arrow. If you ever see this type of an arrow, you will simply say this is a retrosynthetic arrow, okay? And the disconnections, what is a disconnection? This is, you have learned today what is a disconnection. So this is represented by this line, this type of a line. If this is it, you can simply see that this is something to do with the disconnecting the bonds, right? You are disconnecting the bond here between carbon and oxygen. So you learned today disconnections also, and then you have come to know what are synthons. After disconnections, you got the synthons, right, with the in their most unstable forms, and then you get them back to their synthetic equivalents by attaching them or joining them with your counter ions. So I hope you like this video, and you hopefully will be again back with something new, something more interesting, and something more exciting after this, or maybe the continuation of the same subject, same topic, that is retrosynthesis. See you again. Thank you.